produced, how and energy will be utilized, what are the non-renewable sources of energy, how much production is there, what are the techniques used to convert the available energy resources into electrical energy. All these things we will discuss in this chapter. Before that, I just want to make an announcement. Many of you have doubt. So if you have any doubts, you can post your doubts in the chat box, or you will get an option after this class, maybe before some 10 minutes or 15 minutes. I will give you an option. You can respond to my class. You can answer all. You can ask any doubts so that I will answer your doubts. In between, you can raise your hands if that is if any concept is over. I will try to respond to your queries. So please feel free to ask any doubts. This is easy subject. The elective what you have chosen is most comfortable elective, I guess, and also more interesting. I will try to bring out some good slides, PPTs, and images from good internet source, and I will try to make this very colorful and more interesting. Uh, I guess you know me because for your batch, for few people I have taken fluid mechanics lab, if I remember. And so we will continue our journey in this semester with the renewable energy resource subject. Okay, is that fine? Yeah, hope this is fine.
Yes, sir.
Thank you so much. And I will share my PPT. Just give me a second. Yeah, it is getting shared. Also, I need one favor. One of you should take initiative and try to make one WhatsApp group for all these 30 members, whatever in your section B section. You can ask your CR who is having number of all the participants, or you can try yourself. Someone take please initiative to make one group for this renewable energy resources in the WhatsApp, so that I can inform you in advance regarding the attendance or regarding the classes, regarding the exams or anything, so that you can also post your doubts in that WhatsApp group, so that I can share all the relevant materials through that also. So hope someone will take the initiative and create a group. And I have shared my number with some student. I will just text him so that he can. So please someone take initiative. Okay. And there is something problem, I guess, with sharing. One second. Browse Onra PPT. Share. Last class. Yeah. Yeah. The screen came. I think now you are all able to see the screen. Hopefully. Uh, Today we will start with the introduction part. Mm, right. To start with introduction, what is energy? What is energy? Energy is ability to do work. So before that, uh, energy resources. What are the energy sources? in the screen, you can see that wind energy is there, hydroelectric energy is there. In the screen, in the first slide itself, you can see biomass energy is there. Then nuclear power is also there. Solar power is there. Then geothermal is also there. So these are some of the energy sources. Then oil, gas, coal, all these are all energy sources. So what we do with the energy? Energy is used to do some work. There are again some form of energies in the right side. In the right picture, you can see same biomass, water, hydro, all these things are picturized in a different form. So energy is said to be work, ability to do work, where work is defined as the unit force which is applied on any object so that it moves to a unit distance. If a force is applied, then it moves to a unit distance, then we can say that 1 joule of work is done. So if you supply energy to do that work, that energy is called energy used to do the work. How do you get energy? We can put our own effort. Like if you want to move something, you can put our own effort. Like we can take some object, we can place somewhere else. If you want to walk, we can walk. These are all mechanical forms of energy. There is one more form of energy, that is chemical form of energy is there, magnetic energy is there, solar energy is there, light energy, that is called light energy, or radiation energy is there, and nuclear energy is there. These are different forms of energy, and the place where you use the energy is your home generally, or factories, or any place. But actually power generation station is somewhere else. Like you don't get a water source near your home to generate power, so somewhere else it will be there. So some company or energy provider will take care of uh, this option to supply the energy from generating station to the usage station, and that will be distributed through cables to your homes. Then it will be connected to light, TV, fan, radio, or everything. You can make use of this energy situation very effectively. The next slide, we can see the world energy scenario. Before that, we'll see how many types of energies are available. There are mainly three sources of energies. Some they are divided into three sources. They are called primary, secondary, and you should remember this: primary, secondary, and supplementary. Primary is one which supply the net energy quantity required for the globe. So to the whole world, energy supply will be mainly because of the primary sources. Example for primary sources are coal, oil, uranium, and uh, and natural gas. These are some of the energy sources that mainly contribute to the energy content what we are using now in the present situation. But then how it is different from secondary energy sources? Why it is secondary and why it is supplementary? I will tell you the difference. In case of primary sources, if you supply, it takes very little energy to get formed. Coal, uranium, oil, these will take a small amount of energy, but the energy what it releases is very huge. That means it can help us in getting more work done when you take those fuels and burn it. You mean to say that is actually more than 50 to 60% of the energy will be easily released from the fuel. But in case of secondary case, what happens? It takes lot of energy, lot of effort, but what it produces is very negligible. That means there is no net energy. Though it produces energy, net energy is less. Net energy in the sense what you give and what you take. So assume the example what I have given, what is quoted is agricultural. Agricultural in the sense you need to put lot of effort to get some biomass out of agriculture. any agricultural product. The output of that is very less compared to the effort what you put in growing some farm, any crop. That is secondary source of energy. So the net energy output is very less. It is no net energy. We say that there is no net energy, but there is an energy. Like if you burn any wheat straw or paddy straw, you will get some energy. But the effort what you put, or the energy what is consumed by those products is very high compared to the output what they are going to give. Similarly, supplementary source, they don't produce at all. Supplementary source, they don't produce, they only supplement the available energy system. For example, insulation and all, they don't produce, but they will supplement. They reduce the losses, or they try to reduce the losses, and they try to improve the efficiency or like that. So they don't produce energy actually, but still they are divided into three energy sources: primary, secondary, and tertiary. Then in the
Sir,
next
supplementary,
slide,
can you
we
give
can
one
see
more
that
example, sir?
supplementary
Yes, sir.
along insulation is one example. And other example, what can be given? Supplementary along with insulation, we should check. I will just inform you. Okay, let me first finish this. Okay, please give me time. You post it in the group, I will share. Okay.
Okay,
You're
sir.
there? Hope. Yeah. Because I have still more few more slides. I will finish and I will answer your question. So meanwhile, we'll discuss about the energy consumption by the world. So what is the energy consumption by the world? Uh, See, you can see in the slides. First, during 2003, the countries like US and Australia, the power consumption is so high that it is measured to be a prosperous country. So usually there is a concept called, if they use more power, that means they're they're more prosperous country. But this has a negative impact on the environment, that they are going to produce a, what do you say, they're going to produce more carbon footprints. Carbon footprints in the sense, they are going to release more carbon dioxide or poisonous gases into the atmosphere. But in 2013, the power consumption is still more, that many countries, they started consuming more power. And this power consumption is measured in terms of energy per capita. So this power consumption is measured in terms of energy per capita, or we can say that it is defined as how many people are using electrical power divided by total population of the country. That in a one line, we can say it is a ratio of total population using electricity divided by total population of the country. So this will give you the per capita energy consumption. So like this, what it actually says, now all countries are behind using more and more power. In the next slide, we can see that how much population is there in in a country and how much power they're consuming. See, USA, which has only 7% of the population, it is consuming 32% of the world energy, which is actually not so good. But still, they compare that, they show that they are prosperous. That's not so good actually. And then in India, they have 20% of the world population, and they're consuming only 1% of the world energy. You just compare how developing countries and developed countries are making a difference in consuming power, right? Likewise, so what can be concluded is, demand for growing energy is there, but there is no replacement for the fuel. I mean, people are consuming more and more power every year. So there is no alternate source. We have to find the alternate source to supplement this much requirement of the power. So this is the conclusion from the requirement, energy requirement. Next, we can find out what is the our future energy. What happens? Till now, we have some oil reserve. We are going to use that oil reserve, say for some 100 years or say for some 200 years. So after that oil reserves are over, then we have to definitely look into the some alternatives. Current estimate is only for say some 100 years, it seems, for oil. But we have to survive, or if our economy should survive, means we should find some other energy alternative. And one more thing, what I would like to share with you is now the atmosphere has some carbon content, carbon dioxide content, say some X amount of carbon dioxide content. But that composition of carbon dioxide will get doubled within 86 years if we consume power like this continuously with emitting this much of carbon dioxide into the atmosphere. There is a calculation, like if we are using 500 into 10 power 18 joules of energy is being consumed every year. If we consume that much of power in every year, then within 86 years, the atmosphere carbon dioxide content will get doubled. This is actually a serious effect on nature. So everything will get affected. The growth of plants, growth of animals, habitat, cloud, rain formation, global temperature, ice content, everything will get affected if this is continuously allowed to happen. So what I would suggest you is find out some energy source which has very less carbon footprints on the global environment. So we'll discuss about this in coming slides. So next is conventional energy sources. What are the conventional energy sources available? There is another alternative which I would suggest is nuclear power is there, and some more coal reserves are also available. But the problem with the coal reserve is it is more polluting. The coal is also has a very less calorific energy. That means if you burn 1 kg of coal, it produces very less energy compared to the oil, and it is not easy to transport. Unlike fuel and all, you don't find it comfortable to transport the coal. So coal is not much comfortable, or it is convenient energy form. Nuclear has some other problems like safety issue, disposal issue, and all is there. So government now only it should take a preventive measures to save the uh, conventional energies like oil and all, so that it can be extended, its life can be extended, and it can be used in more reasonable manner. So that is the conclusion for these many slides. Now we will start with conventional energy sources. Conventional energy sources. What are conventional and non-conventional energy sources? General concept, the meaning of conventional is nothing but commercial form of energy. Commercial form of energy means you can easily make use of this energy system, and you feel more comfortable in handling this energy system. General example can be given as coal, oil, gas. These are more comfortable and more commercial point of view type of fuels these are. But non-conventional are nothing but renewable sources in the sense like solar, geothermal, tidal. These are energy sources which are non-conventional. Like you don't find it very comfortable and more commercial. They don't. They have very uh, power density. They will produce very less power, but mm, but still you don't get much money out of it. I mean, to say the quantity of power generated or the investment what you make is very much or more compared to the money what you make out of that type of sources. For example, if you want to have a solar panel, you need to invest more. But it's a renewable. It's a renewable, and it has no carbon emissions. So there is a difference between conventional and non-conventional energy system, and also between the renewable and non-renewable source of energy system. So we'll discuss about fuel which are available, that is conventional energy sources. That first thing we can classify it as fossil fuels, then water power, or we can say hydropower, and nuclear fusion. These comes under conventional energy sources. Though water power is a renewable source, it is little convenient to make money out of it, and it produces little good quantity of energy. And fossil fuels are first thing what comes into our mind if we talk about conventional energy. Example for fossil fuels are coal, oil, natural gas. And how it is formed, how coal is formed, we will discuss that in the coming slide. Yeah, this is coal. Sorry. Yeah, coal. How coal is formed? Coal is formed when very olden days, like some thousands of years ago. What happened is, not even thousands, say some before the formation of this species, human species. I exactly don't know the date and time. I will just get you that back with this. What actually happened is, very long ago, the plants or any animals or dead material what is present on the earth surface got buried under the earth due to geographical upheavals activities. That means some portion of sand or soil gets gets filled over the top of the dead animals or plants, or any broken trees or fall down trees, or due to geographical activities, say some earth crust or any layer itself got turned upside down, or another crust got overlapped over this. Somehow the material got buried deep under the earth. Slowly, due to climatic conditions, day by day, the deposition of the sand over the surface of the animals or dead gets increased. If the quantity goes on increase on the surface, what happens? The pressure on that will also increase. So in the second slide, you can see, not slide, actually in the second picture, on the right side, you can see there are some plants, right? So these are the plants. I think if my mouse pointer is visible, these are the plants that eventually gets buried under the earth because of the geographical activities. So due to this, what happens? The pressure increases, and earth crust also has some temperature, and that will heat up this material. So because of this, slowly that gets converted into a fossil fuel. Example, slowly first it will come to picture like first it will get formed into peat, then lignite, then it becomes coal. So these are classified based on their composition. So the quality of the coal. So in the early stages, it will be in the form of peat, where it has a little more moisture and little more gaseous content. Then slowly, gradually, after time goes, with application of more and more pressure and heat, it will get converted into coal. Since this coal is available under the earth, so we have to mine it, we have to get it from the ground. And one more thing, what I can tell you is coal is used for generating power in power stations. There is a boiler, steam boiler will be there. They will put this coal into the boiler. It will be burned. The water is heated, and that will be steam will be supplied to the turbine, and you will get the power. When oil was introduced, before finding of this crude oil, coal was very much popular. But when oil was introduced, coal was little kept aside. The reason is oil is more comfortable. I have told transportation is easy. Oil can flow through pipeline, and no need of any truck or driver. They need not to invest much. So what you can see is more comfortable for way of transportation is available for oil. So people started switching over to oil when oil was introduced, but still coal is available. And in some places where coal is comfortable to use, people are using the coal. So, and then the next, what we can say is oil produces less emissions, coal produces more emissions. So that is why one more reason why coal was little bit kept ahead. Uh, if coal reservoirs are still available compared to oil reservoirs. Oil reservoirs are depleting more faster coal reservoirs. Just give me a second. Yeah, it is seen that up to 200 years the coal content can be utilized by the world. So the reservoir content is there uh, such a way that if we use it with the current usage rate, we can still make use of the coal content 200 years. That means only for two generation. Next generation can only see the coal reservoirs. After that, it will get depleted over. So these are the reasons why people are looking for the renewable source of energies, because everything is getting over. And as I have already told, coal has a property that it is going to pollute, and also the energy released is very less. I mean, if you purchase 1 kilogram of coal, you can hardly heat, say, some half liter of water. But if you purchase one liter of fuel, you may be able to heat full 1 liter like that. That means calorific value. I just gave an example. It is not right, but I just gave an example that what is the meaning of calorific value. So the calorific value of coal is little less compared to the oils. Next, we'll move on to crude oil. So in the next slide, crude oil. So what you see in the right side is crude oil. This is crude oil. What it does is it takes more effort to get it from the earth, and it should be purified. Crude oil will not be used directly. It is very difficult to use the crude oil. The petrol, diesel, everything what you get is from the crude oil. It will be refined in the refineries. Refineries are there in many places in India, like Hyderabad or Mumbai, and in some Kolkata, and in some Chennai maybe, and in some part of the India there are refineries which will take the crude oil, and that will be refined using uh, some distillation techniques. So what actually oil does is, in the present scenario, the world energy needs, mostly 40% of the energy need will be supplied by oil alone. Just imagine 40% of energy need is supplied by oil alone, and this we will get it only for 100 years. From now onwards, if we use it with the same rate within 100 years, I mean, the next generation will also not be able to utilize it properly. So within 100 years, it is seen that the reservoirs are getting. So this is the situation what is there with respect to the oil. We'll discuss that in detail when we actually it is not required. We don't much go in depth with these reservoirs. Just it's a basic definition. We'll go much detail in discussing solar, wind, tidal, all these things. So next is the nuclear power. To say about nuclear power, no, sorry. We have, this is hydropower plant. What is there in the slide is hydropower plant. So hydropower plant, we generate water. We generate water power by using its potential energy. So already in the last semester you have studied potential energy. What is potential energy? So due to the height difference, the water has a potential to flow from one location to another location. It has a potential energy, and in the lab also I have taught you how turbines generate power. Actually, due to this pandemic condition, last semester lab was not complete. But still, I guess for few people, I have explained how energy can be extracted. The equation, if you remember, pressure into discharge. So water, if it has some pressure, and the amount of water what you release to the turbine blades will directly be proportional to the amount of power you get. So because the water level is at some height, when it flows over the turbine blades, it generates the energy. The turbine blades will rotate, and then eventually generator will rotate. The due to magnetic flux exchange, it will generate the power. So advantages is this is very clean. Water energy or hydro energy is very clean, and it is cheap. Operating cost is cheap. That means once everything is set up, the money requirement or cost requirement is very negligible. What is the problem with this is it is not continuous. You don't get water sources throughout the year. Only in some season you will get the water source. And one more thing is construction. To make one water project, water dam project, uh, you just imagine how many years of time the government will take. Say some 7 to 8 years at least it will take to create one water dam project, and one electricity generating station. Then investment, they have to keep aside a very good quantity of money in the budget. They have to keep that much of good amount of money to the uh, building of this generating stations. So it is, these are some of the difficulties that hydropower plant is going to face. And uh, and to say uh, the next is this solar energy. Okay, this hydro, how do you get rains? Rains is again indirect forms of solar energy. So though we say it is a hydropower again comes because of the solar energy. Sun actually evaporates ocean water and that gets converted into cloud. Then the rain comes and that will generate the potential to generate the electricity. So it's an indirect form of solar energy, hydropower. So the next we have other forms of energy, that is nuclear and also biomass. The left side, what we have is agricultural waste or biomass energy, and right side, what we have is actually so sorry, nuclear energy. The next slide, what we have is non-conventional sources. Okay, solar. I thought of completing solar today. I think I don't get much time. Okay, no problem. Coming to the left side, that is agricultural waste or biomass energy. What is biomass? So what is biomass energy? In the first, many of the agricultural waste, whatever is produced, that will be burnt out freely without extracting any energy from it. So in some places, what they do is they will collect all this bio energy and that the biomasses and that will be collected. Then it will be burnt in a confined space, and the heat released will be utilized to generate. These are local power plants. So this is one another energy source what that you can think of generating power. Of wheat, straw,
Sorry, your voice
sugar
breaking.
cane. Okay, just just a second. One second. Hello. Is it now fine? Hello. Can you hear my voice? Is my voice clear?
Yes, sir.
Okay, thank you. So I was discussing about the agricultural waste, or we say biomass. Biomass and biogas, these are two other forms of energies that are available in the nature. Generally, agricultural waste can be utilized to generate electricity. In some parts, that will be collected, that will be burnt in a confined space, and also there is one more method to produce energy, that is, ethanol, right? So that will be converted into ethanol. The available like sugar cane, uh, once they in the factories, once they process it with sugar cane bagasse, that will be used to produce ethanol. That ethanol is also combustible material. It will also release the energy. So like that, agricultural products or biomass can be utilized to generate the power. This is one more renewable source of energy. So this you can get everywhere, every time. And one more thing is biogas. Biogas energy, that is gobar gas. So gobar gas is also one form of energy that you will get from the biomass. So biomass will be decomposed, methane is produced, and that methane gas is used in the generally for cooking purpose, or you can use it for producing electricity also. You can get it done, no problem. But it has a low calorific value. That is why it is not much adapted. And also transportation problem. Say you the expense what it will take to transport these agricultural waste into power production plant is more than what we get the energy from that type of material. So that is why it is not much popular in these days. And another picture what you see in the right side is a nuclear power plant, which is you already know about the nuclear power plants. So what are the problems associated with the nuclear power plants? What are the advantages of nuclear power plant? Nuclear power plant is most comfortable way of producing energy, but it has so many disadvantages. 1 kg of uranium 235 can give energy which is same as 4,500 tons of coal. You just imagine 4,500 tons of coal. Whatever the quantity energy is produced, the same quantity of energy can be produced just with the help of 1 kg of uranium. So that much of potential it has. But problem is disposal. That is highly radioactive. What is radioactive? The after after releasing energy, the isotopes, what are the radioactive isotopes available? The uranium, once it gets burnt, it will release some isotopes. These isotopes are highly radioactive, and that will be there for hundreds of years. It will not get decayed. naturally. It takes hundreds of years. So where do you bury that? These radiations are highly dangerous to our health. So it is highly dangerous. That's why what is suggested is uh, that will be generally buried under the earth, but government is not able to find such a place where it is not going to affect the underground water. So sometimes it may enter into the underground water table, which can spoil the whole world. That's why it is not so safe. Nuclear power. There are many plans going on to find out safe methods to dispose the waste. And in India, we have very few uranium reservoirs available in Bihar, Rajasthan, MP, HP, and in some parts of the Uttar Pradesh. So in these places, we have uranium reservoirs available, but we have some power plants almost in all state, I guess. Even in Karnataka, it is there. I guess it should be there in your place also. So we are getting nuclear power also, but in a limited way. We cannot completely rely on the nuclear power. These are some of the energy sources, conventional energy sources which are available. So what we discuss is, so here you can see, I just forgot to explain you. Coal has supply of 32% of the energy requirement. Oil has a supply of 38% of the energy requirement. Gas is producing about 19% of the energy requirement, and uranium fuel is only 0.13. Hydropower is producing 2% of our global energy requirement. All this total constitutes about some 92% of the energy requirement by the world. And if you see the remaining three last, wood, cow dung, or waste, these three constitutes only 8% of the energy supply. So remaining 8% of the world energy requirement is supplied by wood, dung, and other waste materials. So if we miss this coal, oil, gas, if everything gets over, then there will be a very large scarcity of energy. So this is about today's class. I think you had a doubt. One person raised a doubt regarding. One second, I will just tell you the supplementary sources he wanted example that I will post it to you in the chat section. Okay, is that fine? Find it out and I will just post it to you. Apart from that, this solar energy I wanted to discuss today, but I think for today's class only this much is enough. Tomorrow we'll discuss non-conventional sources like solar, wind, tidal, geothermal, and biomass. I'll post the attendance. Hope please all of you answer the quiz. And in chats, one second. Chats is chat option is off. Not in the charts. Some is answer. Hello. 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 Anybody please answer.
Hello,
is
sir.
Chat option is there? I'm not
Yes.
able to see any conversation.
Yes, sir.
Please,
Chat option is there, sir.
please post your question. Okay. Please post your question so that I will answer it here. Is my voice looking okay? how much frequent it was? Okay, so yeah, please talk. You can unmute your mic, Avinash. You can answer. Was it frequent? Actually, I will not be able to know. Yeah, fine. I think this much is enough for today's class. Thank you for your. Please join for the class tomorrow.
Sir, attendance?
Attendance I will post after this. After this, is that fine? I will disconnect and I will post
Yes.
the attendance.
Okay, okay, sir.
Yeah. Right. Thank you.